Welcome to qnawire.
Okay, let me redraw this graphic here. Maybe not the best redrawing there. There we go. We got a nitrogen here, hydrogen here, and hydrogen here, and I'll put my numbers in a different color. This is 1, 2, 3, 4. Forgot to draw my oxygen. 5 and 6. Okay, and we need to indicate whether indicate for each atom if it a hydrogen bond donor, acceptor, or neither. Okay. Well, let's start with 1. Is this a donor, acceptor, or neither? Well, whenever you've got an electronegative atom attached to a hydrogen, so that could be nitrogen, hydrogen, oxygen, hydrogen, sulfur, hydrogen, right? This bond gets polarized. You get partial negative, partial positive, and you get what's known as a hydrogen bond donor. So these nitrogen-hydrogen bonds here, yeah, definitely. 1 is a donor. 2 is a donor for the same reason, right? It's a nitrogen-hydrogen bond. Okay, what about 3? 3, we're looking at this nitrogen, and recall that our criteria for whether something will be a hydrogen bond acceptor is this lone pair, right? We didn't draw it in and they didn't throw it in the picture, but nitrogen does have 3 bonds and a lone pair in this case, right? So this will be a hydrogen bond acceptor. Okay, let's continue with 4. This is a carbon. It does not have a lone pair. It's not a hydrogen with a bond to an oxygen or a nitrogen or another electronegative atom, so it's neither. Okay, now 5 is an oxygen, and yep, they don't show us, but there is indeed a pair of lone pairs, right? So that's going to make it an acceptor. And finally, we have 6, which is a hydrogen. But this hydrogen is not attached to a carbon, a nitrogen, a sulfur, a fluorine. It's attached to a carbon, right? So it is not polarized, and it is neither.